Hello friends, welcome to Prismatics online class. In this class, we are going to look at the topic complex number. In my previous class, we have explained what complex number is all about, where we said that complex number is defined as the summation of real parts denoted by Rinzi and pure imaginary denoted by Imzi. And we explained the application of complex number and application of complex number in a real life. Today, we are going to take it one after the other. We are going to look at what the proof and subtopic known as what addition of complex number. Now, what we must look at is this addition of what complex number. Addition of two complex number will give itself complex number. When you bring complex number, you bring another complex number. When you add them together, it produces what complex number. So summation of two or more complex number will give us what a complex number. Now let's look at question on the board where they say, given that z1, which is z, is a complex number, z1 is equal to s1 plus i1 y1, and z2 is equal to x2 plus iy2. Now the proof is that I say prove that z complex number is equal to the summation of two complex number. Now we are going to prove this. We are going to solve this question after at the end of everything do we get real part and the imaginary part, and that is what we are going to do. Thank you. Let's solve. Okay, solution. In solving this, recall that z is equal to z1 plus z2, and z1 from this place they told us that it is x1 plus iy1 bracket plus x2 plus iy2. What do we do now? Whenever you want to add complex number to another complex number, this is a complex number to another complex number, and we say that complex number is what summation of real parts and what imaginary part. Now if you want to add this, we add the first real part and real part of the second one, the first real part plus the first real part of the second one. Now secondly, you now add the imaginary part of this first z to another imaginary part of this second z. So that is how to add a complex number. You add the real part to real part and the imaginary to imaginary. In other words, collect all the real parts together and imaginary part together. That is, we have that x1 plus x2 plus iy1 plus iy2. Now let's go. x1 plus x2 plus I is common, so I factor 1 out. We have it as I into what y1 plus y2. Finally, this is what we call Rinzi, denoted by Rinzi, and what Imzi, denoted by what Imzi. So hence our real part Rinzi is equal to x1 plus x2, while Imzi, which is imaginary part, is equal to y1 plus y2, and that is our proof. So summation of two complex number will give itself what a complex number. Thank you. Now example under this, given that question 2, given that z1 is equal to 3 plus 4i and z2 equal to 2 plus 3i. The question say now, find z1, find z1, find z1 plus what z2. How do we do that? Solution, we need to solve. Now, we are going to solve that the complex number z is equal to z1 plus z2. Our z1 is what? 3 plus 4i plus what? Z2, 2 plus what? 3i. What do we do? Add the reaper to reaper. 3 plus 2. 3 plus 2. 4i plus 4i plus 3i. What do we do? Here now, this is 5 plus what? 4 plus 3 will give us what? 7. 7i. Now, here, thanks. Okay. Y. Hence, ring Z is equal to 5. Y mz equals to 7. Okay, that is the answer. So whenever you are adding a complex number to a complex number, you add the real part to real part, imaginary to what? Imaginary. Issue of this I, if you want to add any numbers with I first before the alphabet. We have, like, if I want to say IY, it will be IY. I first before the alphabet. But if it's a number, you have number first before the alphabet. Whenever you are dealing with what? Complex number. IY, this one 4I. So that is how to prove complex number, addition of two complex number. Addition of two or more complex number will give itself what? A complex number. And that is the example on the board. That z is equal to z1 is equal to 3 plus 4i, and z2 is equal to 2 plus 3i. That we should find z1 plus z2. Solution, when you add at the end, you get what? Complex number as our answer. Thanks and God bless you. Remember to subscribe to my YouTube channel, Prismatics Online Class. Bye.